Hello students, and welcome to yet another video on foundation course for business statistics. In this video we are going to study central tendency, or rather one of the measures of central tendency, which is average, or typically it's called also mean or arithmetic mean. So what is average or what is a mean? So typically you can say it's a single value around which the entire data set is clustered. Okay, that's something you can state it as an average. Say for toy example, if I have 5 as a number, 10, 15, and say 10. If these are four numbers I have, and if I am observations, rather I would say observations, and if I am asked to find out what is the mean of this observation, what typically I do is I add up all these numbers. So 30, 40, and I divide it by 4 because there are 4 observations and I get 10. And I say 10 is my average, or 10 is my mean. So 10 is the number around which this data set or this data is clustered. Okay, so that exactly what average means, and that's exactly what the meaning of central tendency is. So clustering around a particular point is termed as central tendency, right? So typically for individual observations, for arithmetic mean, this is the formula. Arithmetic mean is represented by x bar, and the same for individual observation, x bar is equal to sigma I is equal to 1 to n, where n are the number of observation, xi divided by n. So this is the typical formula for to calculate arithmetic mean or average for individual observations, and this is nothing but it's represented by this particular formula. Okay, so let's take a toy example because examples clarify a lot of issues. Okay, so simple example, 6 observations. We have 12, 18, 28, 16, 16, 15. These are the 6 observations. So if I have to calculate x bar, all that I have to do is add all these things divided by 6. So total is 105 divided by 6. So 17.5. So 17.5, x bar is 17.5. 17.5 is an average for this set of observation. Okay, so 17.5 is typically a central tendency for this observation, or most of the data, almost all of the data cluster around 17.5, right? So example 2. Now this example, we have got frequency distribution f. So let's understand the data first. If I am given a table like this, which has frequency distribution, and I am asked to find out what is the average number of marks scored by a student, and the table says I have 1 mark scored by 3 students, I have 2 marks scored by 6 students, I have 3 marks scored by 7 students, so on and so forth. Now what are the number of students I have? Number of students is nothing but sigma f, and that is nothing but 25. All that I have to do is add this column, and those many number of students are there within the data. Those many number of students marks are available with me. Now I also had to, I got n. What do I need is what is the total sum of marks scored by 25 students. what is the total number of marks scored by all 25 students. So how do I get that? So what I will do is 1 mark scored by 3 students. So 1 multiplied by 3 is total 3 marks is scored by these 3 students. 12 marks is scored by these 6 students. 21 marks is scored by these 7 students, so on and so forth. So I get all the rows, okay, which has number of marks, total number of marks scored by that many number of students. And if I summation all these things, I get 74 as total. So I can say 74 marks is scored by 25 students. So average is nothing but 74 divided by 25, which is 2.96. So 2.96 is the average marks scored by one student. So all these marks for 25 students are clustered around 2.96 is what it means. So 2.96 is a central tendency. Next. Now we have a bit of a different data now. You could, looking at the table, you could immediately find out that we have classes here. The class interval given is 10. Let's find out what the data is all about. So we have number of workers employed in companies in an industrial area. So if there is an industrial area, and in that industrial area there are number of companies, okay, so this data all talks about how many employees are employed by this set of companies, right? And then I have to find out what is the average of employee, average employee employed by a company. Okay, so let's go through the data. So 0 to 10 workers are employed by 15 companies. 10 to 20 workers are employed by 17 companies. 20 to 30 workers, 20 to 30. So the figure can be for a company between 0 or 10 or 10 or 20 or 20 or 30. Now this is a exclusive type of classes. So 20 will not be included here, 20 will be included here. Correct? We don't have exact figures, right? So we have class distribution, we have classes, right? So what we have to do is we have to find out what is the mid value of the class, because adding this column will give me what is the number of companies. My number of companies is sigma f, because 15 companies plus 17 companies plus 22 companies, so I get sigma f is equal to n is equal to 100. But if I have to find out total employees employed by all 100 companies, then I actually need to find out some mechanism, okay, which will tell me how many employees are employed by these 15 companies. And the way is, don't take 0, don't take 10. Take a mid value of this class, which is 5. We don't take 10, we don't take 20. Take the mid value of this class, which is 15. So 5 multiplied by 15. So 75 total employees are employed by 15 companies. 255 total employees are employed by 17 companies. And how did I get 255? 15 multiplied by 70. 25 multiplied by 22. 550 total employees are employed by these 25 companies. Like this, I get total 2,780 employees employed by 100 companies. And all that I have to do is I just have to divide 2,780 divided by 100, which gives me 27.8. So 27.8 is the average number of employee per company, right? Now you can go and uh, round it up to 28, because 27.8 employees can't be physically uh, available, so it will be 28 after rounding, right? So let's move on. The same problem can be solved in a different way, and let's see how it is. So if you see, my first three columns, okay, are similar to whatever we have seen in the previous data, but the calculation of average is a bit different. I am not multiplying 5 multiplied by 15. So that's a traditional way of calculating, where I get total number of employees divided by total number of uh, companies. But instead of that, what I am doing is I am assuming some mean as A. Looking at these values, right? Looking at the values, I am assuming that yes, because the number of employees are between 0 and 60, I'm assuming, let's assume mean be 25, right? So 25 employees per company is my assumption. Then what do? I calculate deviation. How do I calculate deviation? I take x, which is a mid value. So 5 minus 20, right? So I take 5 minus 25. So that comes out to be minus 20. I take 15 minus 25, that's minus 10. I take 25 minus 25, this is 0. 35 minus 25, this is actually plus 10. I take 45 minus 25, this is plus 20. And I take 55 minus 25, this is plus 30. Okay, this is x minus, sorry, this is my mistake. It has to be minus because 5 minus 25 is minus 20. So these figures are now correct. So what will happen? So I need to also calculate d dash. So what is d dash? D dash is nothing but d, value of d divided by 10. And 10 is my class interval. How is class interval calculated? 10 minus upper limit minus lower limit, upper limit minus lower limit. That's my class interval 10. So minus 20 by 10 is minus 2, minus 10 by 10 is 1, plus 10 by 10 is plus 1, plus 20 by 10 is plus 2, and plus 30 by 10 is plus 3. Okay, this is minus 1, this is minus 2. Now I calculate f d dash. So I take number of companies 15 multiplied by minus 2, that is minus 30. I have 17 multiplied by minus 1, that is minus 17. And I have plus 25, plus 26, and plus 24. So minus 47, plus 25, plus 26, and plus 24 gives me 28. So my sigma fd dash is 28. This is correct. Okay, so how do I calculate my average? I take assumed average, which is 25, plus 10. 10 is what? 10 is my interval, multiplied by sigma fd dash, which is 28, divided by 100, right? So which gives me 25 plus 2.8, which is equal to 27.8. So this is my average number of employees, and it exactly tallies with our previous example. If you see, in the previous way we calculated and we got 27.8, in this way also we got 27.8. So thanks a lot. In next video we will see few more numerical examples. Till then, bye, and I will upload next video very soon. Thank you.